Thank you, Nick. Yes, this is a combination of, I guess, old colleagues, old friends, looking back to the past. So it's a little bit of digital heritage here, hopefully. So we've got three speakers here. Sadly, Anne Borda can't be here. She's had illness in the family. So Giuliano is kindly agreed to read to her slides. So we'll see how that goes. I hope it'll go well. So I've been involved with, I guess, digital technology since the early 80s, even late 70s, I suppose. And so now I'm interested in conservation and preservation of these things. I've always wondered what the difference between conservation and preservation is. I've noticed you can get strawberry conserve and strawberry preserve. Anyway, apparently there is a difference. But in Oxford, we have lots of places that need conservation and preservation. This is one of the libraries in Oxford where they actually give a definition there that you can read what the difference is between preservation and conservation. So I guess I'm at that stage where I'm thinking about preserving and, even if necessary, conserving my digital heritage, which is in a large cardboard box in my office. And it's got things like this in it. So this is my collection through the years of various digital media that I've got. So you can see there, starting with paper tape at school. So we were doing things on, we actually were allowed to go to the computer and do things on paper tape. Then at university, we moved on to cards, which are actually quite good media because paper is, Graham will tell you, paper lasts, you can get very good paper, but even this not very good paper lasts quite well. You can still read the holes on these bits of media physically. And so my first job, I then moved on to 8-inch floppy disks. I don't know if any of you use 8-inch floppy disks. They're about this size, very floppy. Well done. Yes. So have you got any?
Yeah.
Oh, well done. But the problem is, there they are. Is there any magnetism left on them? I have no idea.
No idea, but nothing to.
Yeah. So you know, there may or may not be something interesting to find there. Whether you can do anything with them, I don't know. Anyway, I gradually moved on to 5 1/4-inch floppy disks. That's the next one. Although it looks quite similar, they're a bit smaller. And then we moved on to the 3 and something inch, slightly less floppy disks, which I have a whole cardboard box full of. And then moving back into academia, we're using large tapes. So I've got one of those, which may have something of interest on it, possibly. Trying to read it, of course, is a bit of a nightmare. Then moving on to various forms of cassette. So one of those is actually the old normal Philips type cassette. So actually they're probably not too difficult to read. But all sorts of other cartridges and things there, different size things. I don't have them. Well, I do have something that can read a cassette, but not all these other digital things. So I'd be quite interested to find something that would read all those. And then, of course, I guess those were in the sort of 90s, those 80s and 90s. And then by the 2000s, we moved on to putting stuff onto DVDs, CDs, and other such things. But I've got a lot of basically empty things with those because I bought them all and then never got around to putting anything on them. So they're probably not worth using, most of those. But you can see there's a range of stuff there. And I suppose because, well, the other way to preserve things, again, as Graham will tell you, is on paper stuff you can actually read. So I do have quite a lot of paper stuff, various qualities of paper. So that first one you can see, well, you can't really see, the one on the top left there, is one of those old sort of thermal printers where if you let any sunshine get on it, it fades away. So it's in a roll. So the outside of the roll is virtually gone. Inside, you can see something because the light hasn't got to it. Now, I think those were from the cassette. So perhaps I can get the stuff off the cassette, even though this may be difficult to get information off. But then the old sort of daisy wheel printers with wide bits of paper. At university, we were able to actually do some graphics there. You can see some that film there, dark film. It's got hypercubes, n-dimensional cubes. I got interested in doing that. How many can you go up to 10-dimensional cubes? You could do that even in the 70s. then I actually went out to Silicon Valley, to California. They have these amazing sort of washing machine sized laser printer, which of course we've never seen in Britain. Well, so you know, that produced basically what you get today out of your printer. So that was being done in the early 80s. And of course, I took my n-dimensional software. You see the bottom right there, I printed some of those out. So I've still got, if it's of any interest to the CAS archive, I can give you n-dimensional cubes like that. Printed out quite a lot of copies. So there's all this stuff, yes, and I was actually starting to publish then. So if you can find another practical computing, you can see a print out of some of these things and so on. And even at that time, early 80s, people were starting to get their ZX spectrums and BBC micros and so on. So I was writing basic software to do sort of graphics. So that's some of my early graphics on the front of one of these magazines that let you use any of these computers that you can see listed there. You have to type it in yourself, I think, but these magazines had all the basic code for those. Then also, my wife was working in the Science Museum, so this is early 80s, and they were starting to use computers actually for displays in the galleries. And she ended up working in the computing section of the Science Museum. And I obviously knew a bit about computing by then, and they were thinking, well, we ought to be doing some computer displays. So they had a Commodore PET, and they wanted to display what CMOS transistors look like. So this is, you can just about see it there, a little demo that appeared in one of the exhibitions at the Science Museum of how a CMOS transistor works. Ever after, if you actually looked at the screen for that PET, you could just see it etched into the screen. I don't know what's happened to it, but anyway, I've got the tape for that, and I'd quite like to resurrect it sometime. And well, then we moved on to colour. That previous one was just monochrome. So this is a BBC micro. Again, the Science Museum was expanding, so it decided it's acquired the National Museum of Photography, Film and Television. Again, they wanted some graphics, so this is a BBC graphic. Well, because it was photography, they wanted to look at different size lenses and so on. So this basically simulated, that's the view looking out over Bradford, and you could press, I want to see what a 200mm lens looks like, 50, etc. And it would gaily, very slowly draw it for you in graphics in front of you on the screen. Again, if Cass is interested in that, but I'm certainly going to try and resurrect that. I haven't done it yet. So I'm just going to give you some examples of the things you have to contest with as you try and deal with all these things. So there's all these different operating systems, different sorts of text. We've moved on from ASCII to Unicode, etc. All sorts of different image formats. I'm sure Sean has to deal with some of this, sound formats, video formats, etc. And all of these, if you've got them, some of these older ones anyway, you've got to try and find some software that will convert it to a more recent format typically. I guess another organisation that's sort of looking at this as well, I'm sure Cass is looking at it, is the BCS Computer Conservation Society. So they have a lot of conservation projects, both looking at resurrecting old computers, the actual computers sometimes. So I think the Harwell Decatron supposedly is the oldest computer that's actually still operating. So if you go and see that in the museum, most old computers aren't actually operating. And then you can do replicas, of course. So there's Bomb, for instance, for the wartime in Bletchley Park. EDSAC they're working on from Cambridge. The Manchester Baby, obviously Manchester, which Alan Turing's working on, and so on. So you can actually make a replica in the hardware. It's one option to try and resurrect these things. A bit like Sean was doing with the buttons and the lights and so on. And then, of course, the other perhaps simpler ways to actually do a software emulator. So there's a list of early computers that have emulators. So if you happen to have some software, you can get it off the original media, then you can get that into one of these and actually run it again. So I guess that's the thing I'd like to do. It might become a paper for Eva if I manage to do it. But that's my one of my plans at the moment, to try and deal with that. Just a few more conservation projects going on. But I think I'm going to hand over to Giuliano now. This was looking more at 80s stuff I was doing, but now I think moving on to the 90s, with more web type things, more recent stuff. So, Giuliano.
Thank you very much, Jonathan. Thanks. So I'm really happy to be here in person and to be here with old friends. And I'm going to present something which is, of course, completely lost into, I don't know if there is a heaven for me for the lost from computer programs. So this was an experiment we did when I was working at the Science Museum with my business partner, Stefania Boiano. And basically, we wanted to create an online 3D environment where people could interact between each other. So it was quite advanced for the time. We teamed up with the Polytechnic University in Milan, and we realized it by using PRML plus Java. It worked in a way, but only in a way, in the sense that it was very difficult to set for the user to download and install all the pieces of the software. And so whenever we succeeded in doing that, then it was great, because we looked with the analytics, and it was quite impressive how much they stayed there, they interacted between each other and so on, because the avatars could chat between each other, could follow each other. You could follow a guided tour, you could fly, and this was the map. So it was modeled after the real museum, but in fact we put some Leonardo's machine around, and you could go into the different rooms and activate them. So for example, this is an aerial screw, which is some kind of inspiration. It's not technically an helicopter, but some say it's some kind of inspiration for the helicopter by Leonardo da Vinci. And basically, if you could, if you activate it, you could have see the real screw basically flying upwards. And the interesting thing was that you could follow a guided tour, and the guide could make you take his or her gaze. So basically, you could see what the guide was seeing, and that was very intriguing. So we presented it at the different conferences, and we got quite a good reaction. We won some awards at the museums and the web conference, and this was an article on the website of the New York Times. And the interesting thing is that they got the idea that the online presence was the most important thing. As you can see, at this virtual museum, you can bring a date. We don't know if anyone ever brought a date on our virtual museum, but for sure, that was the intriguing part. And so we went on working on that. And 2 years later, we, together with the Polytechnic always, we created another version, which was an advanced version based on Java 3D, which was a much better technology at the time. It was easier to install, it was more reliable, and also it was conceptually more advanced, because it was not a recreation of the museum, but it was basically a recreation of an idea that Leonardo had about the ideal city. So basically, Leonardo made many drawings about innovation in architecture and urbanistic, and what we put all of them together. And we created this artificial city where one could go around. And unfortunately, even if it was a very good prototype, the museum lacked the resources and the will to go on. So we only were able to demonstrate it at some conferences. And one thing I think it was quite intriguing was that there were automated avatars around, because one thing that we noticed was that people, when entered the previous system, didn't know exactly what to do. So by having some avatars activating the machines, they acted like a sort of teachers, even if just big. It was easier to imitate them and to realize what you could do there. So this happened in the 90s, and now I'm just going on with the slides by Anne Borda, because in fact she's talking about what went on from there. So the idea that games and serious games became more and more interesting and intriguing, especially during the 2000s. So I'm going to briefly read what she sent us. So the term serious games was defined by games academic Clark Apt in 1970, largely referring to video games going beyond entertainment for learning and education, training, skill transfer, and positive behavior change. And here you can see an interesting image, which is taken from the Sumerian game, which was a game developed in 1964, a largely text-based video game designed by elementary school teacher Mabel Addis, who is credited, by the way, as the first woman game designer. So, not bad. And some say even the first game writer, because she wrote the game. Not just she didn't develop it, but she wrote the narrative behind the game, which was quite intriguing. And it was programmed by William McKay for the IBM 7090 time-shared mainframe computer using a teleprinter to input commands. It was an economic simulator set around 3500 before Christ. So interesting again. And then let's go on. This is the Oregon Trail. Also started as a text-only computer game programmed in BASIC and designed by 3 history teachers in the 70s. The game casts the player as an American settler in 1848, traveling by wagon train from Missouri to Oregon amidst various challenges en route based on historical facts. The game is one of the longest running serious games available because it's gone through many incarnations till today. There is also a mobile version today. Then we've got the digital cultural heritage. So you can see that serious digital heritage games, they support historical reconstruction and preservation, cultural awareness and heritage awareness. They offer free choice learning environments. And there is a multitude of technologies, so internet-based, mobile apps, virtual reality, augmented reality. And this screenshot is quite interesting. It's from Art Tournament, which is basically allows the player to take the role of an art curator and select artworks from various art databases to curate an exhibition. Then we have got The Forbidden City, Beyond Space and Time. This was developed in 2008. It was an early educational virtual reality game where players can interact as humanoid avatars, guests, and explore the Forbidden City in Beijing, China. So this here, virtual reality comes on in serious games. Then this was developed by the American Museum of Natural History, and this is an AR game. So this is a mobile gaming app, Micro Rangers, in 2015, for the public to experience the museum's collections inside the galleries, shrinking the user down to microscopic size to combat threats to biodiversity. Then we have got another interesting project, which is the Project Discovery, which counted thousands of participants. It's an initiative of the Human Protein Atlas, aiming to map protein expression in the human body. Project Discovery enticed gamers to help analyze 250,000 images of stained tissue samples by embedding the scientific data within EVE Online, which is a futuristic role-playing game with over 1 million subscribers. Then we have got this is the Getty. The Getty Museum recent game collaboration with Nintendo's Animal Crossing allows users to import art masterpieces into their digital homes using the International Image Interoperability Framework. The online game called Art Generator also uses a uniquely generated QR code, which holds information on the artworks. And then we are running towards the end of this part with Chauvel, the Dawn of Art. It's a project with Google Arts and Culture, supporting a mobile-based AR and VR interactive using photogrammetry and physical-based rendering. Because the Chauvet Cave is a UNESCO World Heritage Site located in the south of France, dating back to 36,000 years, and is inaccessible to the public. So the idea was to make it more accessible. This is made by the Wilson Center Serious Games Initiative based in Washington, D.C. It has highlighted the social experience in digital games. For example, this is Traveling While Black. It provides a player with the experience of historically restricted travel for Black Americans, tense race relations, and the creation of safe spaces in communities. And finally, Eliza. I guess we all know it. And this is quite intriguing because Eliza was made in the '64 when the original, it just simulated a Rogerian therapist. But what happened recently is that they created a video game a serious game based on Eliza. So the current Eliza game, which has been released in 2020-2021, is done as a visual novel that addresses mental health with the AI supporting decision making. So again, the circle is concluded and goes on. Okay, so thank you very much, and I'm letting over to Tula. But before, I want to show off my new tie. It's a touring tie. So it's, I know this is maybe the only place where people practice. Thank you.
That's awesome. This is just a little.
5 minutes.
Okay, this is just a little poem to end this. Is life the game? Is life the game in a digital frame going to cyberspace? No place for reality, where love's fatality. Choose your avatar face, come join the game. Leave life behind, don't look back, stay on track. Revel in your new identity, future serenity. No place for reality, where love's a fatality. Since hopscotch and double dutch, missing you so much, take me back to reality. Oh, a COVID fatality. Life's too short for video games, love frames the reason for being. Seeing you holding hands in far off lands, je t'aime, c'est tout, being with you.
Tula, Jonathan, and Giuliano, thank you very much. And now over to Richard Whitby from University of Greenwich to talk about from pixels to drones.
So am I able to click through?
Yeah, that should be fine. We'll just full screen that.
Okay. All right, thank you.
One sec, we just need to pull the feed up on
Okay.
the sorry.
Well, while that's happening, I'll just say that.
We just need the feed from that machine to go onto the main.
So I'm going to talk about, well, the title is From Pixels to Drones, Visualizing the Nation in London 2012 and Pyeongchang 2018 Olympic opening ceremonies. And before I start, I'll say, I don't know if it was intentional, but I'm taking us full circle back to Olympic
Sorry,
opening
it's
ceremonies.
slow-
Was
slow-
that intentional? And I'm going to talk about this subject